You could argue, of course, that that's a pretty crazy take, but maybe we do get some oxygen from, hemoglobin and melanin being able to split the water molecule, and then melanin, according to him, being able to reform the water molecule and generate some high energy electrons. So there's so much we don't know there, but certainly we know that melanin is extremely, important. It is a biological semiconductor. It's able to absorb a vast amount of the electromagnetic spectrum, more than any other pigment, any other molecule in our bodies. It's being studied for use in battery technology, right? And if we have this ability to capture more energy from the sun, and then that's really important.
Hello and welcome to the channel. I'm Sarah, and today's guest is Tristan Scott. Tristan's an electrical engineer who's also a health enthusiast, and he's going to walk us through the bioelectronics of the body in the context of the mitochondria, melanin, how to lower our exposure to electromagnetism, and also giving you insights into electronic terms like wideband semiconductor and semiconductor, and how this relates into how biology and we actually function. If you're interested in learning more about quantum biology, I've just made a brand new course called the Quantum Starter Kit, and it's $19, and it walks you through everything from the basics, because a lot of what Tristan's going to talk about today is quite high level. So if you find it's a bit out of your depth, then check out my new course. Welcome to the show, Tristan. Do you want to introduce yourself and tell people how you bridge the gap between biology and electrical engineering? Because we are, as we know, an electric being.
Yeah, thanks so much for having me, Sarah. I'm an electrical engineer by degree. As you mentioned, I kind of really got into health optimization 5-6 years ago when I had one too many concussions, and went down the standard like biohacking, quote unquote, rabbit hole. I was grounding, I was blocking blue light, I was doing a lot of great things, eating grass-fed meat for 4 or 5 years. But then really a couple of years ago, I decided to kind of take a deeper dive, from the surface level, and I realized that my background in electrical engineering was extremely relevant to health and to biology, which I really never thought would be the case. But reading the work of like Robert O. Becker and Andrew Marino, Albert St. George, and some of these researchers who really did groundbreaking work and put their reputation on the line to question the centralized mainstream narrative, made me realize that my degree and my background and just baseline knowledge of electromagnetism actually might be extremely important and really missing from the health optimization, I guess what you would call kind of just the centralized biology narrative that a lot of folks are taught. And the fact that I didn't have to unlearn anything was also helpful. So yeah, I've kind of focused in on that. And I've also written about decentralization. I wrote a book a couple years ago about the decentralization, or the importance of it, in our food and financial systems, called Bitcoin and Beef. And applying those same principles to health, it really aligns. And for me, on my personal healing journey, I realized that the more time I spent in nature, the more connected I fine-tune my lifestyle to what it was designed to do, the better I felt. So now I've kind of dove into the science as to why that's true, and started posting and educating folks on EMFs specifically, but also a lot of other areas of health that are, in my opinion, under discussed, because there's a lot of nuance to them. They are inconvenient truths, as folks like to say. And yeah, it's really exciting to almost, as we were talking pre-show, is kind of like be on this frontier and kind of paving a path that's very multidisciplinary and bridges the gap between, engineering, physics, biology, chemistry, which is really not taught in the traditional schooling to many folks. So yeah, it's exciting, and really excited to chat with you today about it.
Yeah, definitely. Because I think some people have heard Dr. Cruz say things like wideband semiconductors and nonlinear optics, and that that we're an electrical being. So maybe if we just start right at the beginning with something like electrons and hydrogen, then we can work through things like bone being a semiconductor, DHA that again is a quantum molecule, just to walk people in gradually so that those who are quite new to it and don't realize they're not just a lump of meat, and maybe even just the basics of how electric current works, because I think a lot of people think it's the electrons flowing in a wire that gives us the current, and again maybe to educate us from the beginning and then move into something more deep.
Happy to start there. It's really, I guess, important to have like a baseline understanding, and you mentioned a lot of great, I guess, terms there, and starting with electricity. Yes, something that even as an electrical engineer you're almost taught traditionally is that electrons flowing in a wire is how current is really being delivered. But there's actually a more of a debate there, and more of like a nuance that results in the importance of the electromagnetic fields that are generated from moving charges or flowing current, and really that's what's delivering the energy in a field and to power electricity. And it's really kind of like debated, but there's these things ongoing, and that's why you see different components of it, like wireless charging, and the fact that high power transmission lines have to have all these ground clearance rules, is because it's really all about the electromagnetic fields that are generated. But I like to start people in making sure that they understand the electromagnetic spectrum, right? Because this is like a very vast spectrum, and it's all photons, it's all electromagnetic waves at the end of the day. And we are very familiar with the visible light spectrum, and then UV, and then infrared light, because this is what we're getting from full spectrum sunlight. And this is also important to highlight because this is what our biology is really programmed to work with. This is, providing the excitation energy to excite our electrons. And this is a really important concept to grasp. And that's kind of how our biology is run, right? Like we're running off photons, electrons, and protons. And we have this very fine spectrum that we're really fine tuned to take in energy from. I think maybe it's around 1% of the entire electromagnetic spectrum is visible. So talking about DHA, talking about Michael Crawford, and he's uncovered that mechanism on how actually our body is able to interpret color in such an accurate and precise measure. And it's all through rhodopsin, like semiconduction. It's all through the energy coming from the photons. So stepping back to kind of set the scene there, is that the electromagnetic spectrum is comprised of electromagnetic waves, and these waves have both an electric field component and then a magnetic field component, and they are oscillating in 90 degrees in phase with each other. And the frequency of that oscillation is what's really differentiating the type of electromagnetic wave it is. So there's a frequency, there's a wavelength, those are inversely proportional, and then there's an energy of the photon. The photons are massless, but they have momentum, and the frequency and energy are proportional. So a higher frequency is equated to a higher energy level. And that's important as well, from getting back to the semiconductor component of it and how they interact with electrons, because in order for an electron to be excited and reach this higher orbital state, it actually needs to have, according to quantum mechanics, an exact excitation energy match. And this is something that we get from, visible light and UV light, which is tapping into then the ionizing radiation component of it. And this is important because this is kind of where the centralized scientists really get stuck, is that, photons only really impact our biology on this, excitation level, which we know is not true, because we know that there's thousands of research studies showing biological effects of non-native EMFs, and non-native EMFs or non-native electromagnetic radiation coming from things like technology in the radio frequency band, or from our power outlets, power frequency, which is in the extremely low frequency band at 50 hertz where you are or 60 hertz where I am, they argue that they don't have enough energy to basically do anything in our biology. And this is, of course, not the case at all, because the fields themselves have an impact on the way electrons and kind of subatomic particles are just interacting and aligned, the spin they have. And it's not all coming down to kind of the excitation photoelectric effect. But getting back to the difference there is that, radio frequencies from technology is a vast spectrum as well. We're talking about, tens of kilohertz, 100 kilohertz frequency, which is, 100,000 wave cycles per second or oscillations per second, up to now 5G is pushing, 50, 60, 100 gigahertz, which is, 100 gigahertz is 100 billion wave cycles per second. And this is still all lower frequency and lower energy than, say, infrared light and the visible spectrum. However, it's increasing by each generation of technology, and we can get into that, how 5G is different from 4G and 3G from both frequency perspective and then an engineering of the waveform perspective, which is also really important for people to understand the difference between non-native electromagnetic waves and man-made one, or native electromagnetic waves from sunlight. And then we have, as mentioned, the lower frequency power that's coming from our electrical grid, which is only 50, 60 hertz. So we're talking about 50 wave cycles, 60 wave cycles per second. So these are vast differences, but they're all electromagnetic waves. They're all electromagnetic radiation, and they're all of the non-ionizing origin. So non-ionizing meaning it doesn't have enough energy to knock an electron, out of its orbital, out of the atomic orbital completely, and then also not enough energy really to even excite electrons to a higher energy level state, or a higher valence shell, or having a kind of a semiconductive effect on it as well. Some of the radio frequencies can induce actually, all I would say, that's kind of the nuance that's important, is they don't have this direct effect, but they can have a secondary effect in terms of inducing voltages, activating like voltage gated calcium channels via voltage sensor activation, which are very, very sensitive to EMFs. So this is kind of where it gets lost between what people in the centralized paradigm think and then what EMF researchers, what folks like myself and Jack Cruz are talking about, and other EMF experts, is that there are biological effects. They're just different because we're talking about completely different areas of the electromagnetic spectrum. So that's maybe a good introduction, and we could dive into any area of that. There's so much to cover, but I think what's really important for people to know is that our biology is designed, right, to operate off of sunlight, which is the infrared spectrum, which is vast, mostly near infrared, and some far infrared. A lot of the mid infrared spectrum is actually not even making it through the atmosphere to get to the Earth's surface, and then visible light, and then UVA, UVB, right? And then we have a very, very low intensity, low frequency geomagnetic field and electric field in the Schumann's resonance, which is happening. Schumann's resonance first harmonic is around 7.8 hertz. So we're talking about very low frequency, and then we're talking about very low intensity. And then the entire radio frequency spectra is pretty much alien, right? We really don't get any natural exposure to radio frequencies. There's technically a radio window that penetrates through our atmosphere. But I read something from a researcher that said if you put one cell phone on the moon, it would surpass all the natural radio frequencies that we're exposed to at the surface of the Earth. So we're talking about a completely alien spectrum that's very vast, as mentioned, from tens of hundreds of kilohertz to now tens of gigahertz in frequency.
Yeah, that's really interesting, because I think with EMFs, people forget that we've got native EMFs inside ourselves, say from the heart or the mitochondria. And then the Schumann resonance, sometimes for lay people, they understand that it's in the same range as alpha waves in the brain. So again, disturbing the Schumann resonance could, just in simple language, disrupt somebody's alpha waves, and then they can't sleep or they get stressed. So maybe if you want to, before we get too deep into sort of the terminology, talk about the kind of electrical systems we've got naturally in our bodies.
Yeah. And it's funny, right? Because you mentioned the heart, you mentioned the brain. It's like these are accepted electromagnetic aspects of our biology. We have an electrocardiogram, we have electroencephalograms, right? EEGs that are measuring the electrical activity of the brain and the heart. Like this is, been used for decades. Then we also have the MRI, which is a fantastic example of how we are using magnetic fields and then also radio frequencies to to create very high quality images from EMFs. And this all goes back to kind of the fundamentals that, we are using electrons, protons, and photons as, the building blocks, the quantum building blocks of our biology. And a lot of people talk about in our space, right, that it has to be this way because biochemical reactions, they're not fast enough, right? They can't really be the most granular way that our biology is functioning. And we know this, the nervous system, we know that especially that is a very highly electrical component. And as mentioned, the brain waves, and this is proof, right? The alpha brain waves are in the similar range as the Schumann's resonance, and different brain waves are going up, higher in frequency for more alertness, and then maybe lower in frequency for kind of deep sleep and more relaxed states. And this kind of proves the basics of electromagnetic aspect to our biology. But then you can, as mentioned, just go and look at the mitochondria, right? The under discussed aspect of our biology that we can't stop talking about, but the centralized system almost spends no time on, right? Maybe like a couple percent of the research funding goes into the mitochondrial DNA and mitochondrial area, when really this is the crux. This is the most important aspect, and it's really all about electromagnetism. It's taking in electrons, transporting them across respiratory proteins, right, to use that energy to build up a voltage, a proton voltage gradient to power a literal motor in the ATP synthase, a nanomotor that is taking that proton gradient and using it to create ATP. So that, in a nutshell, is proving how important electromagnetism is in our biology. It's using proton voltage, proton current, and then electron energy to fuel this so-called, you could think of it as like a battery. It's more of like a capacitor that's being discharged, and that voltage that's in that electron transport chain in the intermitochondrial membrane space is really important. And this is kind of what's dictating, ATP production. It's dictating free radical generation, which, as it gets out of control, could be leading to oxidative stress and cellular damage and inflammation. So this is all a very tightly regulated process. But then, when you look at the quantity of mitochondria, this is happening on an insanely, high quantitative level. There's, thousands of mitochondria in each cell, depending on the cell, heart tissue, liver, certain areas, brain have far more. And you add up the voltage of around like 150, 200 millivolts per mitochondria across that, membrane potential. And, as Doug Wallace says, we have enough, voltage in our body to, be equivalent to, a lightning strike or a lightning bolt. And that's really what's giving us life. That's what is the difference from us being alive and dead, is our electrical potential at a high level that's, the summation of all the mitochondria like in our cells. And then you can get into water, right? Like water being so important for our biology. We're made of 60 to 75% roughly water, depending on your age, health status. And that's really maybe the main source of, energy or energy flow or energy storage, you could say, right? Building up that exclusion zone. There's, coherent domains there. How the MRI machine works is literally inducing this really high intensity static magnetic field that's realigning the hydrogen atoms in water molecules in our biology, and then pulsing that with the radio frequency field. The water hydrogen molecules absorb that RF frequency, and then they emit it. So they actually work as like antennas. And then from there, we get a nice high quality image using this magnetic resonance frequency. And, it's incredible, but they would never, ever think to understand that maybe all of the electromagnetic inputs, aspects of our modern lifestyles would have an effect on our biology. It's, to me, the biggest ignorance that has maybe existed in the past 100 years. And it's an inconvenient truth. But yeah, that's kind of, some of the basics, I think. And then, we talk about everything, right? DHA and just like reproductive systems. We see the most energy intensive processes in our body being the ones that are compromised first. And this is because of a lack of, redox potential or electrical potential. It's a lack of energy in the system. And something I tell everybody, and something, or the way I think about it as an engineer really is, as a system, we have this system. And whenever the energy source, the power source, the battery in a system is, not operating properly, the whole system is kind of going to suffer from that. And you can always think of a system in terms of, what's going into it and what's coming out of it, inputs and outputs. If we want to optimize the outputs of the system, which is, vitality, libido, energy, physical strength, mental health, what have you, longevity, you want to optimize the inputs. And, in our modern worlds, we've never been more disconnected. We've never had more, incorrect inputs that are causing this dysfunction in the system. And we need to get back to aligning those inputs to what they were designed to be. And that's, a hyper local, environmental, nature first approach to our biology, which has been proven over, hundreds of thousands of years in human existence and millions of years in other biological, existence before that.
Oh, no, that's a really good introduction. And I was just going to bring it back because you kind of laid it in anyway for people who are looking for something practical. So they kind of understand now that it's important to have enough electrons and to be in nature. So when it comes to something like grounding, that there are some studies on it, but in terms of how it actually works from a quantum level, would you be able to walk through that? Because I think sunlight, we just know we feel better when we go out in the sun, and you've explained it very elegantly a lot more. But how about something like grounding? How does that work?
Yeah, so again, thinking about what our body is running off of, and it's running off of photons, electrons, protons, and electrons, being extremely important. Where do we source them from? And, the main sources are food and then connection to the earth via grounding. You can also generate electrons via, movement as well. And we can get into, piezoelectricity later in bone and muscle tissue. But really food and then, connection to the earth are probably the two biggest ones. And this is what's going into that, electron transport chain, right? That's having that energy from transport to build up the voltage gradient that's needed to power the ATP synthase and create water, create ATP, and also building up the exclusion zone in the water then. So the grounding component of it, yeah, it's a real tragedy that we used to, spend pretty much 24/7 connected to the earth. So because of lightning strikes on the earth, we have this pool, this surface charge, this negative surface charge pool of free electrons. And as beings that have, conductive skin, like every other animal, we're able to tap into that surface charge, that pool of free electrons, and utilize that and absorb a small amount of current into our biology. That's DC current, which is important to note there, and use it to fuel our biology. And how that's working, I don't think actually anybody knows for sure, but folks like James Oshman have theorized, other folks in the quantum health space, it is that, collagen water matrix that's really, transferring energy both on an electron and proton flow level, and how that's able to kind of get where it needs to go. But I've interviewed folks like Gaitan Chevalier on my podcast, who alongside Clint Ober and James Oshman have done a lot of the research on grounding. Pretty much those guys have done most of the research on grounding. And he still says that, if you put like a localized patch, it will, reduce the inflammation or pain faster than if you just have like bare feet on the ground, and that you kind of need to have bare feet on the ground for at least 10 to 20 minutes. Whereas if you have a direct line, it might be just a couple of minutes or almost instantaneous. So it's cool to think about that, but then it's also maybe not as instantaneous as we think. Or if you inject something in your blood, for example, like subcutaneously, that is also happening on a very fast level. But to me, it's also something to uncover is where these electrons are going, and it's probably going to be where they're needed most. And we know that it's imperative to have sufficient negative charge in, for example, our red blood cells to prevent things like coagulation and rouleau. And that's a lot of the research on grounding is been using that as kind of an easy way to prove the benefits of grounding, which is fantastic, increasing that zeta potential. But then, we need sufficient charge in our water, right, to build that exclusion zone and have that kind of water battery, quote unquote, from Pollock's work on hydrophilic surfaces. And then we need them as inputs to the electron transport chain. So it seems to me that, this collagen matrix, this intracellular matrix, the fascial network is probably like a likely way for electrons to kind of flow from our highly conductive areas of the hands and the feet, which have, a higher sweat gland density, which is going to increase the conductivity of your skin, having direct contact with the earth, to circulate where it's needed in our body. And again, this is something that we really don't know a ton about. We can only theorize based on what makes sense and make these kind of connections. But it's also something we need to put more research funding into, and something that I talk a lot about is really, if we can improve the ability to get funding and raise money, then we could do so many cool experiments to see this. And grounding is a big one, right? Because I get so many questions about grounding, and it's like, grounding in a city versus grounding in nature, grounding in your outlet versus grounding in a rod outside, or having your bare feet on the ground. And, I have my, perspectives on everything based on what I've measured, based on how I feel and what makes sense to me. But we really don't know definitively the answer to that, and it probably will vary tremendously. And then it's also, how are the EMFs from technology and non-native sources in your environment while you're grounding affecting the benefit, quote unquote, of grounding? These are all, things that we really need to discuss and study more.
Yeah, that's fascinating, because I was just going to add on to that with movement, I always say to my clients that any kind of movement's better than nothing. There's so many reasons. Obviously, with the fascia, because we want it to be flexible without adhesion so it can conduct information. And obviously for the frontal lobe, and then just general mobility. But when it comes to grounding, what would you say? Because you mentioned poles, you mentioned plugging into the AC current, going outside. I think if you live out in the middle of nowhere, that's easy. You can just go outside. What about the people that live somewhere urban? What's acceptable? What's you should avoid, and what's okay?
Yeah. I always tell people that, there's like a good, better, best scenario, and the best would be to have bare feet on the ground in nature. I mean, even bare feet on the ground, kind of like in any grassy area, is probably going to be way better than plugging into an outlet per se. But most people don't have, 10 hours a day to just stand barefoot outside. And that's why, we see like, life at the beach, right? Like is easier. And that's why you see so many health influencers that move to the coast or move to the beach and lower latitudes. And yeah, it is easier for sure. But, a lot of folks don't have that luxury and are at higher latitudes and have winters, and they need to be a bit more deliberate. So for me, what I do is I try and get grounded outside as much as possible. In the winter here in Wyoming, it's not very feasible or realistic to be barefoot too often. So I have grounded shoes that I can wear like socks with, and that's still like grounding me a little bit. I know that from at least like a voltage test that I'm grounded. Now, how many electrons am I absorbing? Probably way less than if I was, bare feet on the ground. However, it's great to be even connected in general because of the benefit from that, and getting, those input signals as well. If you want to talk about a very important input signal, it's being connected to the earth. And that's been proven as well in the research that exists, is that grounding will improve, cortisol rhythms, and thus, your entire circadian rhythm, because you're getting that hyper local input on where you are, what time of year it is, what time of day it is, etc. But going back to grounding habits, yeah, I do that. And then I have a, thin metal pole or metal rod outside my window that I run a wire into my bedroom. And I have like one of those grounding mats that I sleep on, or at the base of my bed, and I put my feet on at night. And actually, this is kind of more recent experiments I've been kind of doing, and I've been, playing around with it. But to me, that makes a lot of sense. I feel pretty good when I sleep grounded like that. And I've tested the outlets in my house, and some of them are grounded, some of them are not grounded. Overall, the wiring in my house is not fantastic. So I have no really desire. I don't necessarily think it'd be a great thing to ground directly into the outlet, especially if the wiring is not fantastic. And I've measured kind of just a difference in potential in voltage from the outlet to the earth ground. So that's pretty common to have, a couple hundred millivolts of floating voltage in grounds, especially if the wiring is not done fantastic. So again, will some people who are extremely electron deficient still get a benefit from grounding into their outlet? Probably. But then you also need to consider your EMF environment. And this is also a really big debate, that should you even be grounding in a super high EMF environment? And, there is no correct answer. But again, it's something that you should be doing anyway. You should be addressing the EMF environment, especially in your bedroom, creating a sleep sanctuary. This is always, the number one recommendation, because this is when, as we're going through all these restoring mechanisms like autophagy and apoptosis. And if you're in this high EMF environment, it's going to affect melatonin production. It's going to affect these cellular cleanup processes, and you're not going to be able to be on, the good side of, the day's onslaught from toxic exposures that we have here in our modern lifestyles. So if you're not addressing EMFs, you may not really have as good of a benefit from grounding. And then you could argue, how is that interacting with our body? If you have this high EMF environment and then you're grounding that through your body, is that even more of a detriment? And some people anecdotally will say, yes, it is a detriment. And some people will say, no matter what, even if I'm grounding in my outlet, I will still have, I've been feeling better. So it's impossible to say, and this is where we need more research. But to me, there's a good, better, best scenario there. Like, yeah, if you trust your wiring and you want to ground into your outlet, like, go for it, see how you feel. If not, if you have the ability to run a ground rod outside your house connected to the ground, obviously don't try and have it like right next to power distribution equipment, for example, and then run a wire, connect that to a grounding mat. that's a better solution. And then best is just, getting barefoot outside and then getting in water. So I'm thankful to have hot springs and a river here in my town. And I spend at least an hour and a half in water, even in the winter time. And this is going to be a great source of, grounding. And also it's going to be a natural Faraday cage, quote unquote, to EMFs because of the high dielectric constant of water. So that's kind of what I do. That's my recommendation. And always addressing your EMF environment first is probably the best thing to do. So going back to what you asked, what should folks do in an urban environment? And this is, the biggest challenge. I post kind of quite often, especially on Twitter, about Wi-Fi, like, hey, like turning off your Wi-Fi router at nighttime is kind of like the lowest hanging fruit in terms of reducing your EMF exposure. And, it costs $0. There's no barrier to entry. The real challenge might be if you have roommates or if you live in an apartment complex. And that's what people always say is, what if I live on the 5th floor in a high rise in a flat in a big city? I'm definitely not going to be able to ground like into the earth via rod. If I turn my Wi-Fi off, there's 20 different routers in, the pickup area. And, my answer to that is it's a tough situation, but any reduction in exposure is a benefit. And you can still, hardwire your internet. You can still turn your phone on airplane mode. It's really important because those immediate sources of EMFs are going to be the most impactful. Like distance inverse square law is your best friend. So even if there's 20 Wi-Fi right around you, yeah, that's not fantastic. But if you hardwire your internet, even if you have a Wi-Fi network on, you're removing that receiver of the laptop from being a foot and a half away from you at all times to just being hardwired. And then you just have the Wi-Fi, which is way lower power. I'm kind of just, being emanated from the source, wherever that is. And then same with your phone. Your phone is way higher power than a Wi-Fi router. If you have it on airplane mode only, or pretty much all the time, besides when you actually need to use it, then it's not going to have as much RF exposure because every time you send a message or make a phone call, that's when the actual like highest RF exposure is. And then again, distance, if you're keeping distance between your technology and yourself, especially like, having it on your body or holding it next to your head, there's way bigger reductions to have from that and just using technology smarter. But, my recommendation to anyone in a high rise in a city would be think about how big of a priority your health is to you. And even if you move from downtown to the suburbs, like let's say 20 minutes, 15 minutes, that could be a drastic difference in your EMF exposure. And if you want to talk about what's to come with like 5G rollout, the millimeter waves, 6G, smart cities, like I really think cities are the absolute last place you want to be if you actually want to prioritize healing or health optimization. And that's just an unfortunate reality of, modern living.
Yeah, the thing about the smart cars, that might scare people a bit now, because sometimes what you don't know won't hurt you for the moment. But I'm aware of the millimeter waves. Just to backtrack to the bedroom, what are your thoughts on things? Obviously, turning off the electricity in the wall at the circuit, like a kill switch, that can help deal with what comes out of the wall. But what about things like canapes and magneticos? What's your thoughts on those in terms of EMFs, magnetism, and helpful or actually makes it worse?
Yeah, I think turning off the power is the best thing you can do. And that's what I've done. It seems unrealistic to some people, but the way I see it, it depends how your circuits are set up in your home. But I'm fortunate to have like separate circuits going to my bedroom. So I just switch those breakers off and they stay off, right? So something you don't want to do, a circuit breaker is not like a light switch. You don't want to be flipping that on and off every day. They're not designed to handle that sort of mechanical stress, especially if they're older. That's just a safety precaution that I'd recommend. But there are solutions like EMF Safe in the US that actually make, and there's other companies out there, maybe internationally, they actually make a switch that you can get installed in your circuit breaker, in your circuit box, that then can be controlled via a remote. So every night before you go to bed, you can just press a button and it'll kill the circuits to the specific areas that you want. And that's really cool. And that doesn't, that's if you're living in a home for quite a long time, then that's, an easy investment to make, maybe, $1,000, and you don't have to worry about EMF exposure as much at nighttime. But that's one of the largest sources is those power frequencies from the wires that are running through our wall. And it's really a shame because when you look into, everyone always says, oh, this is just unrealistic. Like, EMF exposure is just a part of modern living and there's not much we could do. It's like, there's actually like really simple things that if we just made a priority, we could have like 90 to 95% reduction in exposure. And one of those is just using shielded cabling or wiring in our homes, or like steel conduit. So steel conduit, which is like using steel casing in the wires, it blocks 95% of EMFs from the wiring in your home. So then you're pretty much taking your low frequency ELF 50 hertz, 60 hertz EMFs to almost zero. And that's probably the biggest source, especially at nighttime, because you're not using technology as much and it's far higher power, to almost nothing. Or if you use, shielded cabling, shielded wiring, it's doing a similar thing. So there's just one example of how if you're building a new home, and I've done consultations with folks who are building additions and building new homes, like that's an easy one to just, if you thought about it from the start, then you could have a way lower EMF exposure by just the design of your home. But you ask about things like canopies and magneticos, things like that. The canopy, I'm not really a fan, I would say, just at a high level, of any type of Faraday cage. Whether it's a canopy, whether it's paint, whether it's, even clothing, you could debate, because it's an incomplete Faraday cage. So, you're just reflecting the electromagnetic waves somewhere else. And oftentimes wherever the cage ends, such as like the sleeve or your neck, you could actually have like a higher incidence of EMF exposure. However, if you want to protect specific areas like your brain, or maybe if you're pregnant, your stomach and your lap, for your reproductive organs when you're on a flight, that's a different case. But on like a daily basis, I'm not really a huge fan of wearing Faraday type equipment. And even on your cell phone cases and technology, you could debate on how effective they are. I think hardwiring your internet, putting distance between you and the source, and then also putting it on airplane mode, things like that are way more effective than some of the Faraday type cases and equipment. And it almost gives like a false sense of security. So, and again, if you bring a phone or if you bring technology into a Faraday cage, then, so if you paint your whole bedroom and you bring your phone in there, that signal is going to be far higher and it's not going to get out. And then you're just going to be repeatedly blasted with, the RF signal from whatever technology you have in there. But if you have a cell phone tower across the street and you can't do anything about it, maybe it makes sense to hire an expert to paint like a corner of your room wherever that angle of incidence is. Again, this is something that's it's quite nuanced, but it probably makes less sense at a high level to do these things first. I would say always first would be to try and reduce your exposure from just the point source. Like, what is the EMF source? Can you mitigate the duration you're exposed to it? Can you put more distance between you and the source? These are probably far more important and effective, and they cost $0. Even more importantly, the Magnetico, I haven't really experimented or talked too much about it, because I actually would like to have a conversation with the founder. From my understanding, it's kind of, it's like a high-powered static magnetic field magnet that you put on the bottom of your bed. And I have a couple friends who have it, and they say it's great. They say they sleep really well. And that's something that, I'm open to the fact that there are interventions of electromagnetic origin that we can use. And, people like Robert O. Becker were using electricity to heal bone. And there's, things like pulsed EMF devices, and there's a lot out there. I would say at a high level, like most of them, I would be skeptical at the start to how efficacious they are, because a lot of these companies are just trying to ride a wave and do good marketing. Do they really understand how EMFs are affecting our biology? Does anybody understand how EMFs are affecting our biology, like at a very, very deep and thorough level? And I would say the answer is probably no. Like, I've read a lot of papers, there's thousands of papers, there's so many gaps. We don't really know just yet, and they won't even fund, 5G research. So how well do we have, or how, well of a knowledge do we have about how EMFs are potentially improving our biology? I would say we're just scratching the surface. So there's definitely modalities that work that could be beneficial, but I would just offer like a line of skepticism when you're kind of vetting these companies out. And then, is it worth the money? A lot of these interventions are extremely expensive, and that's something that's especially from a mitigation perspective. I'm definitely not a fan of any of the harmonizers or whatever you want to call the pendants and stickers. I mean, the stickers are like, $20, $10. So again, if you put it on your phone and it makes you feel good, who cares? But if some of these harmonizers cost $5,000 and they're just like structured water in a copper tube with a walnut case, like how is that harmonizing the entire electromagnetic spectrum of non-native origin? Like, does that even make sense that that's like conceptually possible? May it have some benefit that we just don't understand? Sure. But when you look at their marketing, when you look at the price tags, does it make sense that this is more something that's really trying to benefit humanity, or kind of just make like a quick buck? So that's how I vet a lot of these things out. But the Magnetico, I'm very interested in. Magnetism is really fascinating, and definitely more even out there in terms of conceptualizing the effects on our biology and even how it interacts in our environment, that I want to dive deeper into, especially being in a very geothermally active area here in Wyoming. I know that there's definitely a magnetic field component benefit to being in such areas. And that's something, Jack talks about like El Salvador and these types of regions. But that's kind of my thoughts. And I'm open-minded to a lot of things, but until there's like good scientific proof, we really can't be sure, to say the least.
Oh, no, I agree. Because actually, with the Magnetico, Dr. Dean Bonnelly did a lot of research, and I'm actually meeting Joan, she runs Magnetico now, and she's his daughter, and a lot of people don't know that. And she did some of the studies with him. So I think Magnetico's been going a very long time. So when it comes to say something like I don't want to name companies specifically, you might be able to guess what I'm referring to. What about, say, a cube that's a harmonizing cube, or something that's sort of a tower that works on a different sort of idea? Did you was that when you were describing something in a walnut case with water and a copper tube, were you referring to that? And then I think I've seen a cube that is, I think this is where we're delving into water and sacred geometry now. And I'm only starting to learn sacred geometry, Dr. Ibrahim's work. So as you said, maybe we just don't know. But from your perspective, with the two things that I've mentioned, do you think it's be careful because they're expensive and we don't know yet, or suck it and see?
Pretty much, yeah. That's a good summary, and I'm excited. And you'll have to connect me maybe with the Magnetico folks, because I do want to learn more. But the the harmonizers and the cubes, it's pretty much kind of what I was talking about there. And again, I'm open to the fact that sacred geometry and water have this power, that this effect that we don't understand. But is it realistic for the price tag to be paying for such a device? And how is it gonna affect the entire electromagnetic spectrum, right? Like, we're talking about power frequencies at 50 to 60 wave cycles per second, and then we're talking about Wi-Fi's at 2.4 gigahertz, 5 gigahertz, which is 5 billion wave cycles per second. Like, these are vastly different electromagnetic waves. And then we can get into the really fun part, is talking about how RF and man-made waves are so different. They're highly pulsed, they're highly coherent. So yeah, I'm very skeptical. And then again, it comes down to the price. But again, I talked to Gaetan Chevalier, and he mentioned on my podcast that he tested like almost all the harmonizers, almost all the stickers, and he has some, like, I guess, alternative like energy field equipment from Japan that they used, that, you know, most centralized research places would not even count as like a real thing. But he said that 98 to 99% of the harmonizers, the pendants, the stickers on the market don't work in terms of their effect on the energy field in a high EMF environment. But he said like one or two do. And he doesn't know why. It might be sacred geometry. It might be, you know, for, you know, understanding scalar waves. I mean, who knows, right? I think it's all plausible, but how can you tell what's real in like a sea of snake oil that's very high cost? I don't know. So to me, if you have the means, you want to try it out, like, go for it, let us know. But I really want to dig into the science. And I do think that's what's so important about talking about EMFs, is because we could actually make a tremendous amount of progress on having the understanding of electromagnetic fields and how it impacts our biology, and then using that as a treatment, as something that could be offsetting the technology use as we're talking about. But we're just not there right now. So yeah, that's kind of my thoughts and what I tell people, right? But I'm very open to some of these things, you know, actually working, sure, but I just want to see the physics and the proof behind it.
Yeah, I think having a false sense of security is dangerous. But back to the Magnetico again, because the Earth's only got 10% of its magnetic field left, that's what makes me think, well, okay, it used to be here, and now all I'm doing is bringing back some magnetism. Whereas with other devices, because I don't understand, I can understand how a Magnetico could work, and also I can look at Dr. Bonnelly's research. So maybe just before we move on, you mentioned often the 50 hertz and the 60 hertz, because, you know, we might as well home in on things we can do about, like Wi-Fi's and phones. What does the 50 hertz and the 60 hertz actually do to our mitochondria? Because aren't they harmonic 100 hertz?
Yeah, right. It's fun to think about how different EMFs are affecting our biology in different ways. And you bring up a great point, and something that I like to say, and what it's called in engineering, is electromagnetic interference. So when you have electromagnetic waves of the same frequency, you're going to have interference of the signal. And anyone who's used like an old radio, or, you know, there's high noise on the line, you know, you can understand this if you have ever, you know, worked in like audio engineering or been to a concert. Sometimes, you know, you experience these things. There's high signal interference. And this is also something why radio frequencies are so highly engineered, is because they're avoiding a lot of signal interference. But exactly what you just said, the low frequency band, to me, is operating in this realm where it's interfering with the innate biological EMFs that we're designed to get an input from. So 50 hertz, as mentioned, is, you know, where the power frequencies are for most of the world. The US is at 60 hertz, and harmonics are extremely important. So the Schumann's resonance is at, you know, 7.8 hertz. That's the first harmonic. But, you know, sometimes the second, third, fourth harmonic, which are just multiples of that frequency, can be higher in terms of their effect or their input on our biology. It just depends on, you know, how the earth is resonating at that point. And resonant frequencies are also extremely important to grasp. And again, we talked about the MRI and how that works, and it's using resonant frequencies to get that image, and our biology is, you know, emitting that frequency in the environment that it's around. But we really are just also scratching the surface on how oscillations, how our cells and our biology are, you know, related to this in terms of frequency. I know Doug Wallace has uncovered that, right, that 100 hertz is an important oscillation frequency for the mitochondria. that's in a specific state at a specific time. But yeah, that's, if you're at 50 hertz or 100 hertz, you're in that same low frequency range. So you could argue that, a 50 hertz signal might be causing some biological interference. And then I was reading a paper last week that talked about how this new study uncovered that all cells are basically oscillating, and we have, different frequencies, different resonant frequencies in different types of cells. The study was looking at like breast cells, and I think they were oscillating at 10 to 30 kilohertz maybe, and as high as in the megahertz range in certain areas. And maybe if they're sick, or maybe if they're healthy cells, they're going to resonate at different frequencies. So this comes back to, again, the non-excitation interactions with our cells, with our subatomic particles. Any of these fields could change the way our cells are oscillating, our organelles are resonating, and that can have an effect on their state in our biology. So I think that's important. And I think that the low frequency fields, because of their very, close frequency range to biological EMFs, especially brain waves, especially mitochondrial oscillations, is going to have more of an interference effect. But then radio frequencies that are completely alien are also going to be able to change the oscillation frequencies as well and affect, the water molecules. So it's kind of just different impacts on our biology, but in different ways. But it's cool to theorize exactly how that's kind of ongoing. And yeah, the magnetic field strength that you mentioned is a fascinating one. And you could dive deep into, how the magnetic field of the Earth is drastically changing in different time periods. And we're actually overdue for like a pole reversal. And could this change everything in terms of how our biology functions? It's all really cool. And they've also proven that we have these, magnetic field sensors in our body. And, perhaps this is how we used to circumnavigate the Earth. So again, we're just beginning to uncover the basically ways our biology are interpreting all these electromagnetic signals. But I will say, from like the work of Dr. Martin Powell, who I often cite, who's big on the voltage gated channels and voltage sensors, is that regardless of whether it's a radio frequency, a low frequency from power outlets, or even static magnetic fields, they can all trigger the voltage sensor in our calcium channels, because it's so highly sensitive to external electromagnetic fields. And even the static magnetic fields can induce an electric field, because, well, and you would think, if you understand physics, that doesn't really make sense, but it's due to, what is it, the second law of induction, is that actually the cells themselves are kind of like moving enough for that the static magnetic field to have an effect and induce an electric field to trigger this voltage sensor, which then is releasing calcium into the cell and causing nitric oxide and all these things to happen. But then I'm thinking, how much of that would be happening natively if we are exposed to some electromagnetic fields, and then how much has that been exacerbated by all of this onslaught of technology and electrical power? So yeah, it's quite fun to theorize and think about how this is all affecting our cells, affecting our mitochondria, and affecting our biology.
Yeah, definitely. So I suppose, just to summarize, with the electricity from the wall, the 50 hertz and 60 hertz, it causes interference, and then in simple language it would cause chaotic cell cycle and disturb the rhythm in the cell, which could translate to inflammation. And for people who just want to know the basics, that would be enough. I also find the magnetism fascinating, because I'm actually rereading Jim Al-Khalili's book, and the cryptochrome receptor is the magnetic receptor in birds' eyes. But like you say, we don't know whether humans have got magnetoreceptors either, because it's not a trendy subject to research. So maybe just to go back and just sort of wrap things up. Something else that people are interested in. So we've talked about hearts, brains, mitochondria, sleeping. What about bones, and the bone being a semiconductor and copper atoms in the bone, and how non-native EMFs could be contributing to the osteoporosis epidemic, which happens in men as well. I used to work in movement, so I've seen loads of osteoporotic people that you would never have guessed would have osteoporosis. Then you see their houses and you think, okay, that explains a lot.
Yeah, no. So that's, yeah, getting to Robert O. Becker's work, which kind of set the scene for a lot of this, right? Discovering that bone is, electromagnetic. It's a semiconductor. It's comprised of collagen, an N-type semiconductor, and then apatite, which is a P-type. So just the difference there is negative, positive, electrons and holes, and basically how it's working is when you have a PN junction, it's called a diode, and that diode is one of the basic semiconductor components. It's one of the basic electrical components in all integrated circuits. And then he also found that the bone emits or fluoresces light, so then you could call bone a light emitting diode. And how he also discovered an important component was that, there's these two copper pegs in the bone, and they're almost operating as kind of like a doping agent. So in a lot of semiconductor materials, it's often doped, or what that means is they're adding another element to influence the conductive properties of the entire material. So adding impurities is affecting the way electron and hole flow is going, and that is what's happening in our bone via those copper pegs. And what he found was that a lot of the osteoporosis is maybe coming from a degradation of these pegs. And I think he related it to space travel in the 80s or 70s, the Soviet space travel that was happening with completely foreign, electromagnetic field exposure was really degrading, the copper and degrading the conductivity of bone. So it's affecting, the semiconductive properties of it, and then leading to things like osteoporosis, which is really fascinating. And then we mentioned piezoelectricity as well earlier. So when a material is piezoelectric, it's able to transform mechanical energy or stress into electrical energy or electrical current. So that's a really important property of bone. It was actually discovered before Becker, but then Becker kind of like proved that. I think it was Japanese researchers in the 50s. And Becker proved that, and that's again why you might feel great from movement. And I think muscle tissues now and other areas of our bodies are also piezoelectric. So it's able to, through movement, through mechanical stress, transform that mechanical stress into electrical energy, create, a quote unquote source of electrons for our body, and why, we may use that then locally to power movement and then also feel better. And then what's really important as well of bone is just the high water content, right? It's surrounded by water. Bone marrow is mostly water. So we're talking about, semiconductors kind of being all over the place, and how our bones are operating, and how, we're functioning at a greater level with collagen, right? Because if collagen's an N-type semiconductor, and that's the source of this main source of this fascial network, then you can imagine how it's a big component of energy flow, of electron flow, and overall power in our bodies.
Yeah, that's a great way of describing bone. And I think also now you've led us into, we know what piezoelectricity is. You've mentioned semiconductors and P and N type. What about something like a wide band or a narrow band semiconductor versus a full conductor and an insulator, just so that people who are sort of understanding what this is, maybe just finishing off on the different types of semiconductor and what the band gap means?
It's great. I think we've touched upon it a few times, but it's good to explain it. So and I know people are always probably wondering what a wide band semiconductor really means. So the band gap is just indicating the amount of energy that is needed to overcome or I should say that is needed to go from the valence band to the conduction band. So it's basically exciting an electron so that it can go free and be a free mobile electron and be able to be conductive. So it's going from that outer shell valence band to the conduction band. So the band gap is the energy that's needed to excite an electron to go from the valence band to the conduction band. So a conductor has no gap. It has zero excitation energy needed to go from the valence band to the conduction band. So electrons are kind of free to move between bands. And that's why conductors are able to conduct very easily without any excitation energy needed or the right environmental stimulus. Semiconductors are in between. Well, first, let's go back to insulators, because we're talking about conductors. They have no band gap. They're free to move from valence band, conduction band. Insulators have such a large band gap. Typically, some say 5 electron volts is the band gap that is, considers something an insulator. Maybe it's higher, 7, 8, 10 electron volts, but it's pretty much like there's no electrical or external energy stimuli large enough to allow that electron to move from the valence band to the conduction band and then conduct. But then there's a big spectrum of that, where the semiconductors are in between. They are, have this band gap, and given the right external energy stimulus, and when we're talking about stimulus, a lot of this time in our biology is coming from sunlight. It's coming from electromagnetic energy, from visible light spectrum, and this is allowing the semiconductors to become conductive and conduct DC electricity.
Yeah, so I was just about to ask you, where does the energy come from? And you kind of read my mind. So just so people know, with a narrow band and then a wide band, you need more energy from the sun to make a wide band semiconductor work.
Yes, exactly. So a narrow band or semiconductor, something like silicon, has a band gap around like 1.2 electron volts, by itself. Again, there's a lot of like different, combinations here, different materials being used, like silicon carbide, for example, is a wide band semiconductor that's being now very heavily used in the electrical vehicle industry for power switching transistors for traction inverters in electric vehicles. Silicon carbide has a band gap of 3.3 electron volts. So that would be considered kind of a wide band semiconductor. Gallium nitride is another one that's popular in the semiconductor industry. So they have a wider band gap, so they need more energy to conduct. But then they're also, these semiconductors are better for higher power technologies in the semiconductor industry. So that's why they're being invested into as future technologies. And again, what's important to note that you kind of asked is that, yes, sunlight is a big, probably the excitation energy that's needed. And I mentioned earlier as well, what's important is that we need to have kind of the almost the match in energy stimulus to excite this electron, or else they're not, the energy from the electron or the energy from the photon will not be absorbed by the electron. It's kind of this crazy, phenomenon. But, talking about just electron volts in terms of what's coming from different wavelengths, like UVB, UVA wavelengths, around 3.5, 4 electron volts. So the wider band semiconductors are really going to need a higher energy photon to make them conductive. And how you can look at this, and what I kind of have a plan to work on as I dive deeper into biological semiconduction, is to map out a lot of the emission and absorption spectras from from biological components like hemoglobin and DHA, because then you can actually understand the band gap of a component of a material, of a biological element, because the absorption and emission spectra correlates to the band gap, because that's what energy is being absorbed by that molecule. So that's, a fascinating one. But, typically the band gaps are going to be, 0.1 to like 5 electron volts, mostly, maybe 1 to 5 electron volts. And again, it's coming back to that, argument that radio frequencies and all these lower frequencies, like Wi-Fi, for example, has I have it written down here. It's like, 10 micro electron volts. So it's so small that it's not going to be able to excite an electron and have that photoelectric effect from a semiconductive aspect of it.
Oh, no, that makes sense. What about melanin as a biological semiconductor, or is that too much of a rabbit hole? Or is it just good for people to know that melanin is not just the sunlight? We've also got a really amazing semiconductor of our own. Or what would you want to say about melanin, just to wrap up on sort of the body electric? Also, one more thing, I was going to ask you about body fat, because obviously that's an insulator. And I've talked to Dr. Cruz several times. And again, this idea of leaking energy, and your body will get bigger to try and keep the energy in. So he was talking about E equals MC squared. So I was just going to ask you, do people build up more and more body fat to try and insulate themselves because they're losing, because people get very confused about Dr. Cruz talking about people leaking light and energy and electrons. And I like to just rotate his thoughts and observations around in my mind and think about it in a different way. But we'll just finish on melanin and body fat, because I think that's something that we all have. So it's kind of relevant to the listener.
Yeah, sure. Let's talk about melanin first. I probably know more about that than the second topic. But yeah, melanin's fascinating because it can absorb really well, like the entire electromagnetic spectrum, you could say. It still has the highest affinity, the highest absorption spectra in UV, and which is pretty much consistent with almost all, biological semiconductors, because it's the highest energy photons. But what's interesting about melanin, because it's pretty much the darkest pigment in the universe, it has a much slower decline. Like it's almost just like a very flat curve that has like a slow downward slope. Whereas things like the aromatic amino acids, they have a very high peak in the UV range, and then it almost drops off like a rock. And same with like hemoglobin, has a couple peaks, maybe in the 400, 500 nanometer before it drops off. But melanin is a very, much slower downslope. So what that's telling me is that, yeah, it's able to absorb energy. It has electrons that are able to absorb energy from a very vast range of electromagnetic frequencies, and that it's probably a very strong semiconductor, and that's been debated in the papers as well. But it's definitely it's able to be used for battery technologies, and it has very conductive aspects, and that's one of the most important things is how melanin is being used in our biology. The eumelanin, the pheomelanin, the neuromelanin. We kind of have inklings on why that's so important, and why neuromelanin, right, when it's kind of being eroded from neural tissue, is leading to things like Parkinson's and Alzheimer's dementia. And it's likely due to that lack of electricity, lack of conductivity in our cells, that lowering of redox potential. And that's what's really important, I think. And I've interviewed Dr. Arturo Solis Herrera, who has some controversial viewpoints on melanin, to say the least. But we know that, or he theorizes that it's able to split the water molecule and generate energy from that aspect. So
doesn't he also say that there's melanin around the mitochondria, and it's the melanin that's delivering oxygen to mitochondria because there's no other mechanism? So it's very interesting, because I think he's a fascinating man, and that's why melanin, I think, could possibly be, maybe it does.
Yeah, no, totally. Yeah, his theory is right, based on like pressure and gas laws, that there's no way the oxygen that we breathe is the one making it to the complex 4 as the final electron acceptor, which you could argue, of course, that that's a pretty crazy take. But maybe we do get some oxygen from hemoglobin and melanin being able to split the water molecule, and then melanin, according to him, being able to reform the water molecule and generate some high energy electrons. So there's so much we don't know there, but certainly we know that melanin is extremely important. It is a biological semiconductor. It's able to absorb a vast amount of the electromagnetic spectrum, more than any other pigment, any other molecule in our bodies. It's being studied for use in battery technology, right? And if we have this ability to capture more energy from the sun, and then that's really important. But it's also acting as somewhat of a light transducer, which I agree with Herrera's perspective on that. So if you have way higher levels of melanin, you need to get way higher light exposure, way more light exposure. And that's something that's important, and that's where it comes back to kind of the the mitochondrial genetic versus Fitzpatrick skin type match that you have. And a lot of us, at least probably like myself and you, Sarah, have like European backgrounds and fair skin, so we're able to get a lot of light. We're able to uncouple really well in the cold, which is something I love talking about, and I love doing as well, especially in the winter time. But then someone who maybe has an opposite, or maybe they have uncoupled mitochondrial genetics, but they have darker skin tone, like they're still going to have to get way more sun exposure to charge up, to gather all that energy from melanin to being able to be utilized in their biology. But it's certainly plausible that this is another source, right, of electrons coming into the mitochondria, right? It's able to be captured by melanin and used as another driver of the electron transport chain and building up that voltage gradient, I would say.
And then finally, what about the body fat? And just to end on an insulator, because we've talked about wires and conduction and semiconductors. And then I was just thinking of a biological insulator. And you can say I've got no idea, but just there are lots of people lots of people in the quantum field have different views about it. And I'm just curious, because Mother Nature tends to have agendas and ideas and often isn't wrong. So what's your thoughts on body fat to do with maybe problems with too much electromagnetism, trying to keep energy in the body that's trying to escape? Just anything. You can speculate if you want, because nobody knows the answer here.
Yeah, I think it's a fascinating conversation, and I don't know too much about that specific, but I can think of going back to like Michael Crawford's work and the DHA, and actually those 6 uninterrupted methylene bonds in DHA, which make it so characteristic to being a biological semiconductor, is really important. And what is a semiconductor? Again, it's basically like an insulator until it's a conductor, right? It's both. It transforms these worlds. But what needs to happen? That environment needs to be in the right energy stimuli in order to transform it from an insulator to a conductor. So that's what's important for people to grasp here, is that semiconductor is the definition of a material, a compound, a molecule, but it's either an insulator or it's a conductor. Like you can't be both at the same time. So DHA is a perfect example of that, is that when it's getting the right stimulus and those electrons or that gradient is able to be built up, and then it's hyperpolarized to where that electron can escape, and then it can conduct via the electron tunneling due to that perfect distance for the electron tunneling to be like a high probability. Then the conduction starts, and it goes from being an insulator to a conductor very quickly. And that's how, Crawford has discovered this unique quantum aspect of it, and how it interacts with, the pi electron cloud of, rhodopsin and the photoreceptors. And it's all, so exciting. And to me, that was really eye opening, actually. Like, I learned a lot. He inspired me to think about things like in a very specific way. But basically, he was talking about how it's an insulator until it's not, and that's all based on the environmental influences. So I think the body fat, you could probably think about this in a certain way as well. When the system is not getting the right inputs, it might be harvesting that energy and then building up that energy in a certain way, but it's not utilizing it correctly. So the system ultimately, like it swells, it gets bigger because it's not able to dissipate that. It's not able to become conductive and then fuel those other reactions. So I think all the input signals to our biology will probably be a good, indicator of why that may be happening. And especially when you think about how specific and how precise all these processes are. And again, what Crawford really talks about is how, like, think of how incredible it is that we're exposed to, I mean, I don't even know the right number, but gazillions of photons, like on a very small time scale, and our body's able to interpret that with such fine accuracy and precision. And it's because of how our biological semiconductors are all set up. But then when that's kind of distorted in some regard, you're getting wrong, you're not wrong, but you're getting more of a distorted spectrum. Let's say a bunch of artificial blue light, sin or minus the healing red light frequencies, and that's kind of going to throw things out of whack. So the body fat perspective is certainly one that's it's interesting. And I mean, in general, it's I guess just a balance of how the systems are meant to be functioning, right? Because you don't want to be too lean either. And definitely, especially Jack's been making that argument as well, as we kind of age, that it's probably using the mitochondrial output and redox potential in the wrong ways if it's all like a zero-sum game from an energy perspective. But that's what's also really, you mentioned like E equals MC squared, and you mentioned just energy conservation. That's also really fascinating to think about how nature has really built in a lot of these systems to offset these things, right? Like, deuterium content will be far lower at higher latitudes than at the equator or at, sea level. And, cold exposure, we're designed to adapt based on the environment we live in and the season that we're in and the latitude that we're in, because it's all about energy conservation. And it is really a zero-sum game. But now we've kind of distorted ourselves from all these proper inputs, and our body has no idea what time of year it is, no idea where we are. We're an endless summer metabolism under an artificial sun, right? And we wonder why the biology is not functioning properly. And it comes back down to how the energy is flowing, how the conductive aspects of our biology are malfunctioning. And it really comes down to a lot of the stuff we talked about. And I think the EMF exposure it's got to be the most pervasive environmental toxin, and the one that's most under discussed, because it really is so inconvenient for us to think about it. But if we just, use technology a little bit smarter and engineered things a little bit differently, then we'd probably be a lot better off. And that's something, I'm really trying to work on, is the education and then the solutions piece. Because as you know, if you don't give people a good alternative or a good opt-out, they're just going to keep doing the same thing for the most part.
Yeah, definitely. So again, you're a real expert in the electrical side and the biology side, and you've got 2 courses. But also, where else can people find you? So maybe if you say what you're offering, you've got your own podcast, the Decentralized Radio. You're also a Bitcoiner, because that might resonate with fellow Bitcoiners. Where can people find you, and what have you got on offer to help them? Because I know you give away a lot of really excellent content as well.
Yeah, thanks so much for having me. This is great conversation. Definitely, I'm mostly on Twitter, on social media, or at least for the most part, that's where I have the largest following and the most consistent posting. I'm at Bitcoin and _beef on Twitter. On Instagram, I'm at Tristan _health. And I wrote a book called Bitcoin and Beef 2.5 years ago. You can check that out if you like. And then I've launched EMF courses. EMF 101 is out right now, and I'm kind of building a curriculum. At least it's going to be like 3 to 5 courses on EMFs, and then hopefully the next set of courses will be on biological semiconduction. I still personally am learning a ton, and I'm really excited. But you could go to decentralizedhealth.io for those courses. I don't know when this will be out, but the next one, EMF 201, which focuses on modern technology like 5G, 4G, electric vehicles, things like that, and how those are affecting, or how those are different from an electromagnetic wave and engineering perspective, and how they're affecting our biology. But what I'm also doing, and what you seem to be excited about, is I'm trying to donate 20 to 30% of the sales from these courses to research. because again, we talked a lot about how there's things we would like to know, and we're kind of just, spitballing on what might be the truth here, based on the knowledge. And a lot of our, insight is coming from researchers from decades ago, from just a handful of them. Like there's really only been, like 5 to 10 researchers that are giving us all this good information. And that's because the funding is so dry for alternative decentralized health topics, because there's no ROI to be made. And it does, that is why I'm a Bitcoiner, and I've been one for years now, is because it does all come back to the money. It all comes back to the fiat system. And, that's another reason why technology is kind of this taboo thing to talk about, is because that's what's really propping up on the last stool, our fiat economy currently. So yeah, check it out at decentralizedhealth.io. And then our podcast is Decentralized Radio. We need to get you on there, Sara, as well. You're definitely on the list, and that'll be a fun conversation. But we talk about all things, quantum, circadian, alternative health. Most 2/3 of it is health. And then we talk to Bitcoiners, we talk to some regenerative farmers, and have some hunting podcasts. Anything decentralized, we're super about. And yeah, we'll definitely have to get you on there soon.
So I'm really grateful for your time. I've really enjoyed this. This video was recorded a while back, and since then Tristan's got involved in a very interesting project with something called the Daylight Computer, which is a blue light free computer. So he's just going to talk you through that and how it's really important for not just our health, but the health of our children.
All right, now I wanted to talk about Daylight Computer. So Daylight Computer is my main venture, my main job. I'm head of operations, marketing, hardware, and it's something I'm really excited about because our mission at a high level is to build healthier technology. So we talked a lot in this podcast about EMFs and the issues with man-made electromagnetic inputs. And for me, the really biggest detriment in modern society in terms of how it's impacting our health, physical and mental, is our technology. And as an engineer, I knew that it didn't actually have to be that way, that we could make simple fixes to the light spectrum, to the fact that it has to be pretty much used indoors, to the RF EMF component to technology. So Daylight Computer, we are a startup that is trying to do exactly that. So our first product that we've launched to the market last year is a tablet form factor, and I'll show a bit more of it in a second. But we invented a new display technology, because what is the main interactions that we're having with technology? And that's through the screen itself. So the screen is the most problematic, you could say, because that is the one that is very heavy in blue light, has an unbalanced light spectrum with a cool white LED kind of peak in the 440, 450 nanometer, which is really dopaminergic, really stimulating, and really disruptive to our circadian rhythm. It can, in isolated fashion, disrupt mitochondrial health in your retina, and the list goes on and on. And this is a problem. And you can redshift your phone, your computer, you can wear blue light blockers, but those are really all band-aid solutions. So what if we change the light spectrum at the core, at the LED hardware level? And that's something we've done. So in our backlight, in the Daylight Computer, we have a custom amber spectrum that is blue light free, amber in tone. It's actually amber in color, so you can see it a bit better at lower brightness than, say, a fully red-shifted screen with iris or f-lux. And that's true because our eyes are actually more sensitive to orange and yellow and green light. And when you have a tiny bit of green, more yellow, more orange, and red in the spectrum, you're actually going to get the best combination, more similar to a candle or a fire spectrum of light that is more broad than a very isolated red LED or a red shifted phone or laptop. So it's both the combination of the light spectrum and the brightness intensity of that light that will disrupt your sleep, your melatonin production, your circadian rhythm. So that all does matter. And the other component to the light is how it's delivered. Most people don't realize that modern displays are flickering on and off hundreds or thousands of times per second. This is because the way they control brightness is actually, instead of pushing lower current through the diode and lower voltage, they instead turn the diodes on and off periodically at different what's called duty cycles. So if they want to turn the brightness down, they increase the amount of time off. This is very disruptive to our eyes and our brain, especially on OLED screens, which is what your smartphones use. They oscillate in the hundreds of hertz range, and that's very problematic, agreed in many research standards, even electrical engineering standards. So daylight, our backlight, our LED brightness control is also flicker free. So the light is being delivered continuously and it's not flickering. The other main benefit is you can see here that it's actually very much able to be seen, and I'll show more in a second, outside. So because the daylight computer has a reflective screen at its core, it can be used outside. So right now, there's no light being emitted from this device. And that's powerful because I can be outside, grounded in nature, and actually be productive. Right now, I'm learning Russian, and I can actually, unlike most e-readers, play videos on here. And it's really cool because we can also take notes, and you get this paper-like experience. So you're almost writing on a digital physical piece of paper, magic paper. We call it live paper display technology. And if you've ever used a Kindle or a Remarkable or similar e-reader, you kind of understand the benefit of an e-ink type product. But the downside is that the refresh rate was always too slow. So here at Daylight, this is actually what we have theoretically solved. We've made a fast e-paper display that's very snappy, that can thus be used outside, and you can read research papers on it. It's amazing for note taking because it does feel like a magic piece of paper. And then because it's now fast enough, you get full internet functionality to where I can pop open my email, I can pop open WhatsApp and send messages. I can pretty much download any app on the Google Play Store because we're running a custom modified version of Android, and be productive in nature and not have to worry about the glare, the lack of brightness on a modern display, similar to a MacBook or an iPhone. I can't even see my iPhone screen that I'm recording this on because it's so bright outside. And the whole premise is that we're working with nature at Daylight. We are reflecting the light in the environment back into your eyes. That way you can use it outside and get the benefit. The battery life is much longer, tens of hours instead of just a couple. It won't overheat as easy because when we have no backlight on, we have far less power consumption and heat dissipation occurring as well at the hardware level. So those are a few reasons why what we've done here at Daylight Computer is very intentional. And our whole premise is, how do we get back to a world where tech is just a tool instead of a portal into an artificial reality? And it is color, it is monochrome, but guess what? That can be helpful because you might be a lot less likely to scroll on Twitter, let's say, when it's black and white. It feels like a newspaper as opposed to a hyper stimulating, hyper addictive interaction with this artificial reality that we are now almost always sucked into. So that is kind of the high level overview of what we're doing here at Daylight Computer. We launched in May of 2024. It's been an incredible response. We're really excited about what we're doing. We have a lot more products in development now. We're building a community, and really the whole entire premise is to have devices that are effective and helpful as tools so we can get work done. We can take advantage of the benefits of the internet without having the detriments, the fact that it can't be used outside in the real world, the fact that the displays are hyper stimulating and addicting, especially for children who are even more susceptible. And now our one-to-one screen learning, 12 to 14 hours of screen time a day. And it doesn't need to be that way. There's simple engineering changes like moving from PWM dimming to DC dimming, getting a better light spectrum. Next on my list is to get better EMF mitigation in the RF emissions piece. We're having a software update coming soon called Smart Airplane Mode, where it's just going to go in airplane mode on standby. And we're going to have, accessories that are also going to make EMF mitigation much easier. So that's our roadmap, right? How do we create technology that is truly synergistic with humanity? And we appreciate your support, but we would love your feedback and to hear ideas. So you can contact us, hello@daylightcomputer.com. If you have any in-depth engineering or ideas on how to directly mitigate, contact me directly, Tristan@daylightcomputer.com. We're at Daylight Co on socials, and our website's daylightcomputer.com. So we appreciate your early support, and thanks, Sara, for allowing me to spend some time going into this.
If you're interested in learning more about the Daylight computer or purchasing one, the link's in the description. Use code Dr. Sara for $25 off your order. Thank you very much for watching. I hope you found this useful and informative. If you want to learn more about quantum biology, but something more basic, then check out my quantum starter kit, and the links are in the description. If you're looking for more long-form content in a readable form, then if you could check out my quantum Substack. If you're looking to work with me, I've got a coaching group and the links are in the description. So we have a live Zoom call, a forum, and you can ask questions about science, about yourself, about quantum biology. And I also do little presentations in the group, and sometimes I share some of these presentations on YouTube. For example, the mitochondria video that I uploaded before this one. Thank you for watching, and see you soon.